And we're back, folks. All right. So, again, this is section 1-7, day 1. The warm-up is up here, so if you'd like to pause, do the warm-up, and then play whenever you're ready. I'm going to go over the homework here now. All right. So, again, we're going to go through question 21. Let's make sure we have our homework out to kind of go over it with us. Here is question 21. Now, this one is weird for one reason. What happens when I subtract the 3 from both sides?
It goes away.
What's that?
It goes away.
That's true. But it goes away on both sides, doesn't it? When I move this 3 over to the left side by subtraction, I get a 0 over here. Sorry, my S's look like 5s. Now, I'm going to divide by -2 over to the other side. 0 divided by -2 is 0. Now, I get this weird, we never had this case yesterday, where we had the absolute value is equal to a 0. Is 0 positive or negative? Neither, right? 0 is neither positive nor negative. So what I do is I say, well, since this, if I say this equals 0, if I tried to say this, would that make sense? -0? No, because negative times 0 is just going to be 0. Anything times 0 is 0, right? So this would essentially just go back away. And then look, I've got 2 of the exact same equation, right? So if you ever get the absolute value is equal to a 0, you only have one solution. We add the 5. 1/4 S is equal to 5. So we divide by 1/4, which is essentially multiplying by 4. So S is equal to 20. That's why there's only one answer there. 20. That's it.
How do you know what number to add or subtract from the total? Like, do you just go left or right?
What number to add or subtract from the total? I'm not sure I know what you mean.
So,
give me an example on.
So, like, I added 2.
Oh, be careful there. Even though it's a negative, that's multiplication in between that absolute value and the -2. Yeah.
Oh, that's why.
If there's ever a number directly next to the absolute value, you're going to need to divide that over, not add it over.
Oh, okay.
Yeah. Okay, give me one more to go over from this homework assignment. Give me one more to go over.
Can we do 20?
Sure. Let's go over 20. And I'm going to clear ink and hide 21. All right. You might be tempted to say no solution right off the bat because it's equal to a negative. But this one is not no solution. I can't make that decision yet until I divide over that -3. And then, presto changeo, it's positive. Magic, nothing up my sleeves. Math magic.
Just written on the board.
Then we subtract. Now, here is where we decide, okay, I will have solutions. Sid doesn't like my kind of humor.
I like it.
Oh,
Yeah, that's because you're weird humor.
that's true. 1 minus 2/3 v is equal to +3, or 1 minus 2/3, excuse me, 2/3 v is equal to -3. Okay. Now we subtract the 1 over to the other side. Get -2/3 v is equal to 2. And then we divide by -2/3. And I believe that's -3. I think it's still up here. Yeah, 2 divided by -2/3 is -3. Then I subtract the 1 from both sides. I get -2/3 v is equal to -4. And when I divide by -2/3, that's going to turn it positive. And I think that's still up here too. 4 divided by 2/3 is 6. +6. So those are my two solutions here. 6 or -3. Okay. Questions about that? Remember, 2 solutions for each one. The only special cases where is when the absolute value is equal to a negative, or when the absolute value is equal to 0. Those are the only two special cases that we may have. Let's look back at our warm-up. So get your warm-up out and take a look here and follow along. First thing here on the left side, I'm going to subtract the 5. X minus 2 is equal to 4. We say x minus 2 then is equal to positive 4, or x minus 2 is equal to negative 4. So x is 6, or negative 2. Questions about that? Yes, sir.
I did it differently, but I got
Relax.
the same answer.
Well, okay, that's fine.
I added the 2 in the parentheses first. We got the same answer. Is that bad?
You should not have gotten, like, you added the 2 up here before you made your 2 solutions.
Yeah.
You got 6, but how did you get negative 2 if you added 2 to 4?
Yeah, that I didn't get, but I got 6.
Yeah, you can't do that. It needs to be both solutions. You got to make it from here, then break this apart. Okay? Let's take a look at our next one. Add the 3 first. Negative 2, 5x minus 1 is equal to negative 8. Now we divide by negative 2. Absolute value 5x minus 1 is equal to positive 4. Now we make our 2 solutions. Now we say, okay, we got 5x minus 1 is equal to positive 4. Or 5x minus 1 is equal to negative 4. And we solve each one of these. I add the 1s and then divide by 5. Add the 1, divide by 5. X is 1. Or add the 1, divide by 5. Negative 0.6. Remember that you've got to have both answers there. It's not acceptable just to have one answer. You can't just solve the positive version and just not solve the negative version. You have to solve both versions. Questions on the warm-up? Okay, let me hand out the guided notes for today. Now, I am just going to forewarn you. Some of you guys are going to leave here today and be like, that is the hardest lesson that we've done. Some of you guys are going to leave here today being like, I don't know why people thought that was difficult. This lesson, there's like no middle ground. It just depends on how your brain works. Some of you guys are going to get this really quickly and think it's easier than other problems. Some of you guys it's going to take a little bit more work. It's going to take a little bit more brain power. Now, just as a reminder, we have our test next Thursday. Remember that interims get pulled on Wednesday. We all know what that means? Your memory classes may have talked about it, but interims get pulled on Wednesday, which means that I'll have to go and input your grade from Canvas to Hack. And then that's when they decide, okay, are you going to stay in on Fridays or are you going to go have your hour lunch still on Fridays? Remember, anything lower than a anything C minus, anything lower than a C minus, you get that hour lunch on Friday. So that means if you have any like homeworks you want to turn in and get your grade up a little bit, please do so before Tuesday of next week. All right, section 1 said we're going to spend 2 days on this. Rewriting equations and formulas. So what is a formula? Let's define ourselves a formula. Basically, a formula is any equation that states a rule for a relationship among quantities. What we're going to be working with in this section is equations that only contain letters or contain more than one letter. Like every equation that we've done thus far this year has only had one variable in it. Just one. And then you solve for that variable. You get like x equals 5, or like x equals 10. Or you could possibly get 2 answers. But there was only ever one variable, right? I didn't have x's and y's in the same equation yet. I haven't had a's and b's in the same equation yet. So what we're going to be doing now is taking multiple variables within the same equation. So why are we doing this? Well, This is used a lot in science, and let me give you this example. The distance is equal to rate times time equation. I mean, you could use this all the time when you're traveling anywhere. If you have distance, if you're wanting to find distance, all you need to do is take the rate times the time. Say you're traveling at 60 miles per hour and you're going for 3 hours. What's the distance? 180 miles, because it's 60 times 3. Distance is equal to rate times the time. If I know I need to get to my location in 2 hours, I know how far my location is away. So you've got 120 miles to travel, and I got to get there in 2 hours. I know I'm going to have to travel 60 miles per hour. Okay? You can use that equation and move things around within that equation to let you solve for distance, rate, time. Doesn't matter. You can use that equation, manipulate it, rearrange it so that you can, use it in different ways. That's really what we're going to be doing today. So how do we do it? What's the process in moving things around in an equation? Well, I got 3 steps for it. First step is locate the variable that you're trying to solve for. Find it within the equation and circle it. That's going to be a very important step because usually we never move that variable. Usually we never move that variable. We just say, okay, we're going to leave it where it is, move everything away from it. Second step, identify what's being done to that variable so that you can move those things away. What operations are being done? If they're adding, subtracting, multiplying, dividing, what's happening to that variable? Because step 3 says use inverse operations to move everything else away. Move things away from that variable. Basically, you want to get the variable you're solving for, you want to get that variable alone. And that's what's really important here to remember. A lot of people are going to say to me, I don't know when I'm done with this problem. I don't know when I'm finished with these problems. You're finished with these problems when you get the variable that you're trying to solve for, you get it completely alone. That's when you know when you're done. Because on the other side is going to be a combination of letters and numbers. No longer, not in this section, are we going to have like x equals 5. We're not going to have x equals a number. We're going to have x equals a whole nother equation. Let me show you how here in a second. Okay, our first example here. X plus y is equal to 15. You notice how every time, looking down at your papers, every time I tell you what variable to solve for. And each time it's different. What variable am I solving for in this one? What's it tell me to? Solve for x. I have to tell you. If I don't tell you, I haven't constructed the problem correctly. So what I would like you to do is go for x, go find x and circle it. And don't move it the rest of the problem. My goal is to get everything else away from x. Now, what's being done to x? What's the operation that's being done to x? Addition by y, right? How do I undo addition? Subtraction. Now, if this was like x plus 10 equals 15, I would be subtracting 10 over to the other side. If this was x plus 5, I'd be subtracting 5 over to the other side. Since it's y, I'm just going to take y and subtract it over to the other side. And again, whenever I do to one side, I got to do to the other. I come down for my next line. My y's canceled on the left side, leaving just my x on the left side, which is great. That was the goal. Now, this is different now. If I had actually had 15 minus 10, I make it 5. If I had actually had 15 minus 5, I make it 10. If I had a number, 2 numbers that I could simplify, I would simplify them. Can I simplify 15 minus y? No, I can't. They're not like terms. So you literally just leave it as 15 minus y, and that's it. I shouldn't have boxed that yet. I should have checked and said, okay, is x completely alone on one side of the equation? Yes. That's when I know I'm done. No numbers, no negatives, no other letters with it. I'm completely done when x is alone on that side of the equation. Let's try another one. Solve y is equal to a times b times c for b. So first step, circle the variable that you're trying to solve for. Go ahead and do it on your papers there. Circle the B that's sandwiched in between the A and the C. What operations are being done to B? Multiplication by what? A and C. I'm multiplying by A and C, right? Now, if you're doing the same operation to two separate things, what you could do is actually do that operation, undo that operation at the same time. I multiplied by A and C, so I can divide by A and C. At the same time, yes, at the same time, on the same step. So since I was multiplying by A and C, I'm dividing by A and C, which gets me y divided by AC is equal to B. Is the variable that I'm solving for completely alone? Well done. See, some of you guys are going to like these because is there any computation happening? Am I going to my calculator and like plugging in any numbers? No. So some of you are going to like that in that respect. But some of you are going to hate that because there's no x equals a number and it's going to drive you nuts. It's not x equals 5. It's not x equals 10. It's not x equals a number. It's just x equals another equation or b equals another equation. Just moving things around. We will do a problem like this like 50 times a little bit later on in the year. We're taking an equation 2x plus 3y is equal to 6, and we're going to solve it for y. Basically what we're doing here is taking an equation that's in what's called standard form, where we have x, y, and then a number, and what we're going to do is going to solve it for y to put it in a different, to look at it a little bit different way. So first step, locate the variable you're trying to solve for. This is a weird one because I've got two operations being done to y. What's being done to y? I see two things happening to y. What's being done to y? Sid?
2x is being added and it's also being multiplied.
Good. 2x is being added and it's also getting multiplied by 3. Now remember, reverse order of operations. So I've got addition and multiplication. I gotta undo my addition first. How do I undo addition? Subtraction. And what am I adding to 3y? I'm adding 2x, 2 and x. So I will subtract the whole chunk, 2 and x. Get that whole term over at the same time. It will go away on the left side, leaving me with just a 3y on the left side is equal to 6 minus 2x. Can I make that like 4x? No, I can't do that. Those are not like terms. I cannot do that. Now, here's another tricky part to this one. Is y completely alone? No. The 3 is still next to it. So now I have to divide by 3. Now, when you divide by 3, if you've got multiple terms on the other side, each term needs to be divided by that value. Each term. So 6 needs to get divided by 3. 2 needs to get divided by 3. Each piece on the other side gets divided. Whenever you divide over, each piece gets divided. So that's going to cancel the 3's on the left side. That's going to give me y completely alone. 6 divided by 3 is 2. And then I've got 2/3 x. Now you could make that 2x over 3. That would be equivalent. But I'm going to write it at 2/3 x because pretty soon that's going to be our slope for a line. We just actually put it into slope intercept form right there. You didn't even realize you did it. All right, questions on that. And now I say, is y completely alone on my left side? Now I'm done. That's how you know you're done. As long as the variable you're solving for is completely alone, then you're done. All right, let's take a look at the next one. M over x is equal to k minus 6, and I'm going to solve that for m. All right, so what's being done to m? By?
X.
And how do I undo it?
Multiply by x.
Good. So I'm solving for m. I'm dividing by x, so I'm going to multiply by x. Now, just like division, I've got to multiply to everything on the other side. I'm basically going to distribute to the other side. So I've got x distributing to the k and the 6. So m is equal to k times x minus 6 times x. Oh, sorry, that's a minus sign between it, not a times. Minus 6 times x. Kx minus 6x. Is m completely alone?
Yes.
Then I'm good. I'm done. Box the answer. Let's do one more. Okay, this is a little tricky because I'm solving for c. Go ahead and circle c. Now, back when we had these problems where we had a number in the bottom of the fraction bar, what did we do with that number in the bottom of the fraction bar?
Multiply.
We had to multiply it first, right? Same thing applies here. I've got to get that t over to the other side first before I can break into the numerator of that fraction. So let's do that. Let's multiply by t over to the other side first before I break into the numerator of that fraction. So r times t, or rt, is equal to c minus s. Okay, I'm still getting c alone. What operation does that? Addition by s. All right, so that leaves us with an rt plus s is equal to c. Questions about that? RT plus S. Yes?
After you do this one with place.
Yeah. Okay, let's take a look at some word problems. Okay? And I have to edit this one here. Your paper says to solve for I, correct? Okay. All right. The formula for an object's final velocity is F is equal to I minus gt, where I is the initial velocity, g is the acceleration due to gravity, and t is the time. Do I really care what these things represent? No. Not for our purposes. What I want to show you here is that oftentimes in science, you'll have to rearrange equations so you can look at it in a different way. Like, for example here, this F is equal to I minus gt. I wonder what we can learn if we solve it for I. Let's see. F is equal to I minus gt. Let's solve this equation for I. How do I solve this equation for I? Anyone?
You subtract I.
Oh, don't want to move the one I'm trying to solve for.
Oh wait, you add gt.
Exactly. Thank you. Exactly. Add gt. So that's going to give me F plus gt is equal to I. There's my equation. But now what does that mean in terms of the context? Well, that means now that you could solve your initial velocity. Like if I wanted to find out how much my initial velocity, if I threw something, whatever this may be in this situation, what was the initial velocity of the object? Well, if you had your final velocity, you could add it to your acceleration due to gravity times the time it took for whatever you're looking at, okay? Final velocity plus gravity times time. That will give you your initial velocity in this case. Let's do one more. The formula for the area of a triangle is area is equal to 1/2 base times height. We know that formula. 1/2 base times height, or base times height divided by 2. Okay, so that means if I want to solve that formula for h, if I want to solve that formula for h, what would I do? What would I do? David?
Divide by b.
And?
1/2.
Good. Because I'm multiplying by 1/2 in b, so I divide by 1/2 in b. Now that's going to get me area divided by 1/2 my base is equal to my height. And that's totally fine. You might say 2a over b. That would be fine too. But for our purposes here, I'm completely fine if we say that. So what is that? What are the implications of that? Well, if I told you a certain triangle's area needed to be like 100 meters, 100 square meters, and then I gave you, okay, but the base has to be 20 meters, you would be able to find the height needed to produce that area just by taking the area divided by half the base. And that would give you the total height that you would need. It doesn't tell you the shape of the triangle, but it would at least tell you the height of the triangle that it would need to be. Okay. All right. That's it for the notes. So long. If you're watching along at home, make sure you turn in your assignments.